look at average value of a function together. So what we want to do here is we want to find the average value of this function over this given interval. So how would you do it? The way which we're going to do it is integral of a to b of the function f of x dx all over b minus a. That's basically how we're going to do it. So if you're to apply that idea to this question, what we end up getting is from 0 to 4, 4x minus x squared dx all over 4 minus 0. That's basically what we end up getting. Then when you evaluate this one, then we get 2x squared for the first term, and next one is x cubed over 3. That goes from 0 to 4 all over 4. So once you plug in 4 here, we're going to get 16 times 2. We get 32 minus, in this case, we get 64 over 3 all over 4. So now, then what we end up getting is, on the top we get 32 over 3 all over 4, which ends up being 8 over 3. Becomes our final answer. So in other words, for this function, if the function was what represents the height from 0 to 4, the average height of this function, average y value of this function over this interval was 8 over 3. All right, let's look at number 3. Same idea. So what I'm going to do is from 1 through 8 of cube root of x dx all over 8 minus 1. That's how we're going to start. But if you remember, x to the, this is the same thing as x to the 1/3 power. Using the reverse power rule, we can see that it will be x to the what? 4/3 power and 3 over 4. And that goes from 1 through 8 all over 7. So when you plug in 8, then cube root of 8 becomes 2. 2 to the 4th power becomes 16. So 16 divided by 4 becomes 4. So my first value becomes 12. My second value becomes simply as it is, which is minus 3 over 4 all over 7. So then what we end up getting is, this is the same thing as 48 over 4. So 48 minus 3 becomes 45. So what we end up getting is 45 over 4 all over 7, which becomes 45 over 28. So that's basically what we end up getting for number 3. All right, let's look at the next question, number 5. Same deal here. 0 through 5, t e to the negative t squared dt all over 5 minus 0. But in this case, what I'm going to do is I'm going to use the u sub. If you let u as negative t squared, then du becomes negative 2t dt. Since I don't see negative 2 in the front, what I'm going to do is this will be equal to 1 over negative 2. And then you're going to get e to the u du. Then essentially, all over 5, right? Essentially, now this one becomes negative 1/2. E to the integral of e to the u is e to the u anyway. So what we end up getting is e to the u, which is negative t squared, which goes from 0 to 5 over 5. So then let's look at it. When you plug in 5, then we get negative 1/2. If you have to plug in 5, we'll get e to the negative 25th power. And then minus, when you plug in 0, we're going to get 1 all over 5. So when I rewrite it, then I end up getting 1 minus e to the negative 25th power. The reason why I switched them is because of the negative sign. All over 5 times 2, which is equal to 10. So that becomes our final answer. Alrighty. Let's look at number 9. So number 9 actually has a few parts here. First, we have to find the average value, just like what we have done before. And find c such that the average value of the function is in fact equal to the value itself at that particular point. So now, and then sketch the graph of f and then rectangle whose area is the same as the, so then basically what we look at, let's try to look at the A portion first. A is integral from 2 to 5, and then x minus 3 squared dx all over 5 minus 2. So that means when you take the integral of this one, we're going to get, because the inner function is x minus 3, so I don't have to worry about the u substitution. This will simply be x minus 3 to the third power over 3 all over 3. But this one goes from 2 to 5. So when you plug in 5, it's going to be 2. So what we end up getting is 8 over 9 minus, when you plug in 2, then we're going to get negative 1. Negative 1 to the third power is negative 1, so we get negative 1 over 9. So we get 1 becomes my answer. Alright, so then, so we found the average value. Part B, on the other hand, is average value has to be equal to f of c, that means 1 has to be equal to c minus 3 squared. Now in this case, we are assuming that c will be between those two, the values, even though it doesn't say so over here. So when we get to realize that c minus 3 should be equal to plus or minus 1 when you take the square root of it, then c must be equal to 3 plus 1 or 3 minus 1. So 3 plus 1 gets you 4, 3 minus 1 gets you 2. But in this case, just like the mean value theorem, the value that which we are looking at is the value between 2 to 5. So 4 will be the value that which we are looking at. But 2 will be accepted if they don't mention about the c being between 2 and 5. But if they were to say c has to be between 2 and 5, only 4 will be accepted. Depends upon the context. In this question, they didn't say one way or the other, so we can accept both. Now let's look at part C. They want us to sketch the graph. So now, if I were to sketch, I'll try to sketch this one by hand a little bit, as much as I can. So here it goes. So we're gonna have a parabola. So let us say this is equal to 2, 4, 5, and 3. Then we're gonna have a parabola that touch the x-axis at 3, and it goes up. Like that. That's the graph. Now, so let me try to highlight this one with crayon, red crayon. So that's the original area. Now, and then of course when x equals negative 2, it was equal to 1. And when x equals 5, it was equal to 4, I believe. But since average value equals 1, that means I'm going to go to 1. And then I'm going to highlight it with my blue crayon a little bit. So then you can see that the area of the rectangle here, designed by the average value of the function which we found, which is 1, will be the same area as to the area under this curve, which is the area of the red one. And that's how we can sketch part C. Alrighty. With that one, I'm going to close it for homework review. See you later.